Ashule Muthul. Ashule Muthul. Muthul o fihlile bana. Fihlile Muthula. Ashule Muthul. What's going on? Hey, not shading. Hey, boy. Yes. Yeah, today we are going to deal with the what? Hey, bit of a load shedding. Let's go. Welcome to the Physical Science Live. Hey, welcome to the Physical Science Live. Eh? Yeah, this is just the work of yesterday. This is history. And with the quick explanation, we were learning how to draw free body diagrams. So we're learning how the system works. We were learning different types of the forces. And we were learning a lot of things yesterday. Yeah, thanks for joining, guys. Thanks for joining. Yeah, this is just the information that you see here. This is just the information we were doing yesterday. And I believe everyone is covered. And those who are back, welcome back. Those who just joined, thanks for joining. Yeah, thank you very much for joining. So, with a quick brief, I will just run through whatever that we were dealing with yesterday. For those who were here with us yesterday, and for those who just came back now, because now we are going to be busy with another story. We are going to talk about another story. We are not going to talk about this, but we are going to talk another story. Because people, they've been asking me to draw. People, they want to learn how to draw free body diagrams. And people want to learn how to deal with different kinds of the systems. Okay, the blue light. Okay, I feel like this light is fine. So yeah, let's start, guys. Let me look for something to wipe this guy. Yeah, I'm coming back. Yes, yesterday we were dealing with calculating tension. Yeah, tension, acceleration, systems, hanging systems, calculating acceleration, tension, learning when the system is at the constant velocity. We learned a lot, Thank you very much for joining, guys. So let me look for something to wipe this board so that we can start. Okay, before I erase this one, let's just do it. Yesterday we learned that this one is going to be an applied force. This force has an influence for the movement for this car. This force, okay, let me just say quick. This force, it takes this car to move forward. Obviously, we learned that this is an applied force and the tension is dragging the car. The tension is dragging the car. Obviously, this car is going forward relative to this force, tension. There's no applied force, I told you yesterday, right? And we learned that friction, friction, it's there on the surface. When the objects are hanging, we don't think of friction unless we talk about air friction. But air friction is always neglected. Ne? The air friction is always neglected, so we can't talk about friction on hanging objects while you're at high school. On a high school level, we can't talk about friction on hanging objects. But we know whenever these objects are on the surface, they will experience a force of friction. And we learned about the normal acting on the object relative to the surface, and the normal is always going to be perpendicular to the surface. And we learned again about drawing the free body diagrams of objects acting on objects acting. So yeah, I just going to run through, like I said to you, we are going to run through this object free body diagram representing the object by the dot. Because of this applied force, we're going to move forward, and this is going to be our applied force, and this force, this force is going to be our tension, but it's a bit long. Tension, friction, this is going to be the T, this is going to be the friction, and we're going to have our force of gravity and our normal force. This is the Fg. And you should bear in mind that the normal force is acting relative to the surface. Obviously, the normal force is acting relative to the surface, and it has to be perpendicular to the surface. And we are going to talk a little bit more about the normal force. But here, it will just be up relative to the surface. Yeah, so Fg, the Fg part, the Fg is the force that is exerted by the earth on the surface. It's center to center. It means Fg, it will exert a force in this object from its center, and the normal force will be exerted on this object relative to the what? The surface, and the normal force will be 90 degrees to this surface, and the Fg is going to act from the center to the center. That's what you need to understand about this concept, guys. Thank you very much for joining. Really appreciate it. Thank you very much for joining. So now we talked about the tension. Obviously the tension, that's where third law occurs, guys. That's where we get the third law. The action, there's a force that goes that side, and the force that goes in this direction, it is caused by this car, right? This car, it's causing this force to be in action, but the reaction is the force that this car, it uses to drag the forward car. This car, it uses the reaction force to drag this car to not to go on. This one says, let's go with this force, and this guy says, wait a little bit, I'm going, but wait. I'm not sure if you get the knowledge there, because this guy says, hey, let's go. This guy, he drags. That's why we have an action reaction on the tension force here, and we have the resistive force on the wheels. Obviously the content of the surface, obviously we learned about it. We learned about the content of the surface, which is the coefficient of friction, and the friction is the force that is exerted by the surface to the wheels of the car, which is acting as the opposition. It's acting as a opposition for this guy. So here we will get our friction. We'll get our friction being the force that is acting as an opposition. It is acting as an opposition. It resists the forward force, obviously, because it's acting in an opposite direction. So yeah, that's the story of yesterday. So I hope you got the clear picture of this one, but I won't go through the calculations because today I want to go into the new business. We have to talk about the business of the day, right? So yeah, I'm going to wipe this, and yeah, I'm going to wipe this. Yes. So Yep. Now, physical sciences. Let's catch up. So, I want to talk about this force being pulled in that direction with the F applied. This is going to be our F applied, and whenever we have our F applied, and let's assume that the surface is rough, we are going to have our friction being acting in that direction, right? So since this F applied is going in that direction, like I said to you just now, the friction will act as an opposition. It will prevent, like it will drag this force, it will drag this force to not to go forward. But this object will continue, like will go forward. But because of this friction, it will, so it means that this F applied, in order for this object to go in that direction, this F applied, it has to be more than friction in order for this force to accelerate in that direction. So now, whenever we have this guy moving, this friction, we will consider it as being a kinetic friction. Kinetic friction, kinetic means movement. So this friction will be kinetic friction because of the object is moving. Now this force, it will be less than this force, so it means that the object is moving in that direction. So now let's look at the difference between these two forces being unequal, and we have a scenario. Let's have a scenario where we have these forces being equal. Maybe let's say here is 10 newtons and this side is going to be 10 newtons. Okay, comments, everything is opposite direction. What do you mean, Mr. Albito? What do you mean? Please be specific. Please be specific. So now I have 10 newtons being my FA. Ne? I have my 10 newtons being my F applied, and I have my 10 newtons being my friction. So do you think this object here, it will move? Who can tell me? Can I have a yes, no? Oh. The mirror, ne? Oh. Ish. Let me try and mirror. Ish. Is it fine now? Is it fine? Yes. Oh, okay. Thank you very much. Thank you. Is it fine now? Okay, thank you. Oh, hey, Mos, it was a disaster, Mos. Yo. It was a disaster. But it's fine. Thank you very much, Mr. Albertino Williams. Thank you. I really appreciate that. So, yeah. Do you think with this... I want to challenge you. My guy, I'm not in a competition, boy. Me, I'm in the helping mode. I'm not in a competing mode, my friend. Competing? No. Let's help other students to learn and to be like you. Let's not challenge. Like, I'm not in a mood. After that, what will I benefit? The knowledge that I have, I'm sharing it. I'm not... Most I will die with my smartness. I rather share. Huh? It's pointless for us to compete, my friend. So, do you think this object will move? Yeah, it will no. Yes, no, yes, no, yes, no. Yes, it won't move, right? So since this object will not move because of why, the forces are equal. So whenever I'm going to draw my free body diagram, so this force F applied and that force F friction will be equal. Even the length will be equal. What is the length of the free body diagram represent? What is the length of the free body diagram represent? Who can tell me? Come on, come on, come on, come on. Yo! You helped me, Mr. Williams. I saw man. Even the people, they are just passing by, but I can see now they are here. Yes, thank you very much. The length represents the magnitude. Ne? The magnitude, right? So, by looking at this, it will not move. So, will this be the kinetic? We will consider this being kinetic. We'll consider that as being kinetic. Thank you, thank you, thank you, thank you. This, it won't be kinetic. It will no longer be kinetic. So if we watch this one, how it will be our free body diagram? Our free body diagram is going to be like this will be long, and the arrow that I'm going to draw this side, it has to be longer than this one, or shorter, or equal. Can I get the answer? Longer, shorter, or equal? Since I'm drawing the friction, it's going to be shorter. It's going to be shorter. So this is going to be Fk, since we consider this as being a kinetic friction, right? So this one is going to be Fa. So let's go back to this one. This one is going to be Fa. So now here it's no longer going to be the kinetic one, right? So here is going to be static friction. So do you see the difference? This will help you whenever you want to define, maybe they're asking you, Hore, define static friction, define kinetic friction. This one is the force that opposes the motion of the moving object relative to the surface, right? It opposes the motion of the moving object relative to the surface. That's why we say it's a minimum force that opposes the motion of the moving object relative to the surface. And when we come to this one, we are saying it's the maximum force that opposes the motion of a come on, type there. I'm starting the definition. Is the maximum force that opposes the motion of what? Of what? Of a moving object, or of what? Of a moving? Is it the moving? Thank you, Belicious. Yes, thank you very much. Stationary object. This one is a stationary object. It, like this force, these two forces, they balancing this one. If I have to pull this force with 10 newtons, it means I have to apply a force that is more than this 10 newtons. I have to apply the force that is more than the maximum force. And what is the maximum force that I have to overcome? The maximum force that I will have to overcome is going to be this guy. This guy is the maximum force that I will overcome. So whenever I overcome this force, if I overcome this force is the maximum force that will keep this object from moving. That will keep this object from moving. It will keep it stationary. Ne? It will keep it stationary. It will keep it stationary. Then whenever you have your applied force overcoming this force, we are no longer calling that a stationary, we are no longer calling that a static frictional force. It's now being converted into what? A kinetic frictional force, because of now is the friction that is applied to this force. It is applied to this object relative to the movement of it. Yes. Yeah. And thank you very much for joining. Yes, FG is relative, like wherever you are experiencing a force of gravity, guys. Ne? Doesn't matter wherever you are, you can be wherever. As long as you have mass that is significant, you will experience force of gravity. So I just wanted to emphasize this as being our first lesson of the day. This is going to be the first lesson of the day. So let's go to the question and let's see what is it that we can get. Ne? Let's go to the question and let's see what we can get. 2 minutes, coming back. Looking for a question for you guys, ne? So that we can see how is this going to work for us. Okay. What's up? Yeah. I got it. So let me wipe here. I'm back now. Okay. Never mind the drawing. Okay, let me confirm something. Come in. Thank you for your patience. So this is going to be the 8 kg. And this is going to be the 4 kg. Yeah. Coming with something. So okay, the the coefficient of the kinetic friction for both blocks is going to be, let me say UK, it's going to be 0.4 for both blocks, and the angle here is going to be 40 degrees. Yeah, coming with something juicy. Right. Yeah. Hey. Can I get a 10K? Now I'm looking for my likes now. Can I get a 10K, 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 10K? Please tap the screen. But they don't share the same surface. The UK is the same. Yeah, it's the question. It's the question. It's not me. It's the question. Like the question, it says for both blocks, maybe it can be possible that they share the same coefficient. Maybe this part of the surface and this part of the surface, they are from the same metal. It can be possible that they might not share the same surface, and if the surface is not the same, the coefficient won't be the same. So it means, or if they have the same coefficient, it means, or the surface here and the surface here is going to use that coefficient. So I don't want to focus on the questions too much. I want us to focus on the logic of the physical sciences. Ne? So tell me, in the 4 kg block, do we have a force applied? Do we have a force applied? Do we have a force applied? On the 4 kg block, do we have a force applied? I want to see people. Yes. So on the 8 kg block, do we have a force applied? On the 8 kg block. On the F. But we are told that this system, do we have a force applied here? Do we have a force applied on the 8 kg block? People. Well, people. Do we have a force applied here on the 8 kg? Okay. Okay, it's fine. We will fix this issue. So, guys, we are told that the system, the whole system is accelerating in this direction. Right? We are told that it is acceleration in that direction. Yes. A force is a pull or push. The force is a pull or push. So does it mean that on the 8, if a force is a pull or push, it means on the 8 kg block, do we have a force applied? That's what I'm asking. If a force is a pull or push. So if force is a pull or push, what about the magnetic force? Do we have a pull or push on the magnetic force? Do we have a pull or push on the magnetic force? Because as far as I'm concerned, we have attraction and repulsion. Hey guys, let's clarify the matter. Ne? Let's clarify this matter. Let's clarify this matter. I feel like it is very important for us to join this live. Ne? Force applied is the one that is pull or push, right? The force applied is the one which is pull or push. Tension relative to the string. Each and every force, it has its own purpose. Ne? A tension, it is relative to the string. But a tension, it is relative to the string. It is not a force applied. Who told you tension is a force applied. Like a force applied, since when it becomes tension? Now I answer every comment. More especially people who needs to know the content. You will know it. Guys, tension will never be a force applied. If tension can be a force applied, we might as well say what the normal is force applied. Okay? Yeah? We might have say like arere force of gravity is force applied. Okay? Should we say that? Tension is relative to the rope. Thank you, Menzi. Thank you very much, my friend. Is the force on the rope. Thank you, Kamu. I like people who communicate. Let's talk. Or a string. Thank you. Guys, let me tell you something. Each and every force, it is applied relative to its purpose. Force applied is a pull or push. Finish. It's not every force that is pull or push. Ne? It's not every force that is pull or push. On the tension, we have third law. On the tension, we have third law. We have the force that it is being applied this side. We have force that is being applied that side. So what yo is going to be a long one, Mr. Legit check. Izoba indenyana mfana. Angazi mara ungatype message ku WhatsApp ngiyayibona prior. Message ku WhatsApp ngiyayibona. Ngawa ungatype. Yes, so guys, don't be hey, cause wabona. Yes, so now let's talk about this scenario, guys. Guys, I suggest you listen to me. And I will confirm the comments. Because I feel like there are some people who are trying to prove a point here. And trust me, my friends, I will answer each and every comment because I know what I'm talking about, my friends. I know what I'm talking about, and I will answer every comment. So yes, tension, it is relative to the string. Force of gravity, it's a non-contact force. It's the force that is exerted by the earth on the surface. Normal force is the force that is exerted by the surface, being the resistive force of the force of gravity. Do you get what I'm trying to say here? Am I clear? Or maybe am I speaking Chinese? And the force of friction is the force that opposes the motion of the moving or stationary object relative to the surface. So that's why I'm telling you now, Hore, each and every force has its own purpose. Not every force is an applied, is a pull or push. Come on, guys. No. Guys, I wish those ones who come here and try to cleaverish my content, shame. They won't win because you were sent. Vele ke nako ya lena vele. Wa bona 2 o'clock ke nako ya lena la the kids. Mara re nka se lebitsele ka mabitso. Re lefa modimo. Let's go tlaishega. Guys, let's continue. Let's continue. So we are having this 4 kg forces, ne? We are having this 4 kg, ne? No. Okay, it's mechanics, guys. The topic is here. It's mechanics. We are jogging our minds. I take for everyone by now. They have studied mechanics, ne? All of the laws. Newton's first law, second law, and third law, ne? First law, second law, and third law here. But in this case, I don't see, like, I wouldn't say this one, I wouldn't say it's first law, because of, as I tell you, where the system is accelerating, the system is accelerating, ne? As the system is accelerating, it means what law, I'm asking you now, what law do we talk about if the system is accelerating? Mechanics, my brother. School edition is not varsity edition. This one is school. Thank you very much. It's going to be the second law. Is the second law, ne? Since this one it becomes the second law, since this one is the second law, because of the second law, it tells us that the object will accelerate in the direction of the force that is directly proportional to the acceleration and inversely proportional to the mass of an object. Did I define it right? Can someone? What is the cause of the system's acceleration? Is the force. The force causes an system to accelerate. Yeah. The force, if you have a force, you have acceleration. The force is independent, the acceleration is dependent. Am I clear? Or am I lost? Tholakele. No, let me not answer some unnecessary question. We are not talking about the gravity, by the way, but we are talking about it relative to this. Thank you very much, Mr. Legit Chat. Now we are having this guy. Let's start with this guy, ne? Let's start with this guy and take it here. Ghana, yesterday. Okay. What are we representing? What are we representing this object by? I want to see all the people they were attending yesterday. But if you have, thank you very much. Yes, thank you very much. I see now where I have my people. So we are going to represent this system with a dot. Ne? A dot. Now we are drawing a free body diagram. Ne? As we are drawing the free body diagram, now we want to ask ourselves, if this object has mass, it has what? If this object has mass, we have what? Thank you. Is it FG? What is GF? Oh yeah, it's GF, gravitational force, FG. Yeah, we have FG. FG, and now, is this the only force that will have? What is the resistive force for this guy? Yeah, it's going to be the normal force. Up, down, up. Normal force. Now, these are the first 2 marks of the day. Now we have to ask ourselves, okay, now, demand why man? Only bad influence. So now what causes this object to move? What causes this object to move? Thank you. It's going to move where? That side. With what? Tension. Thank you very much. And what do you hear? Obviously, when you go that side, what do you hear? What is it that what is the sound? What do you hear? Thank you very much. Yeah, because it's on top of the surface. Obviously, I'm going to have friction. What is wrong about this? What is wrong? Because this free body diagram is wrong. What is it that is wrong? Because we are correcting some students who are drawing this kind of a free body diagram. What is wrong? Okay, I see Minkateko. No, 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 no. Guys, come on, come on, come on, come on. What is wrong? What is wrong? What is wrong with this? No, okay, okay, guys. Ne? I guess it's one person who got this. Yes, yes, but I don't want to confirm your answer, legit check. But it is correct, right? Oh, yes, because this one, I told you, hore, at first I told you this is an acceleration. The acceleration is not zero. Let me do this. The acceleration is not equals to zero. So the horizontal forces, yes, the horizontal forces are balanced and this system is accelerating. So we can't have this friction being equals to the tension. Ne? That's the only thing that is wrong here. We can't have this tension being equals to this friction. Can I get a thumbs up if you hands? If you hands. Yes, thank you very much. So now this system is accelerating in this direction. Ne? Now we have to have this friction to be a bit shorter than this tension in order for us to know, okay, the magnitude of tension, it has to be longer than the magnitude of friction, since this system is accelerating in that direction. Not always the case, but if the system is accelerating, we will. Don't rush. I told you, let's not focus on the calculations yet. Ne? We want to focus on the logic behind this system and the logic behind the free body diagram. The free body diagram is something that you shouldn't what? You shouldn't underestimate though. You shouldn't underestimate. That's the correct English, ne? Yeah. We will talk about the direction. Guys, don't rush, man. Step by step. We are still here, guys. We are still here. And we know, I told you, this system is accelerating in this direction. Right? So, we take the direction of the motion as positive. We take the direction of the motion as positive. Or you want me to say like that? Not always, ne? Not always. Sometimes you can have this system and it becomes stationary. But in this case, the acceleration is not equals to zero. It means this system is accelerating. It's accelerating in this direction. Ask it, I'm preaching this song. I'm preaching. So can I get a 20K? Is it clear? Is it clear? Can I get a thumbs up? Can I get a thumbs up? Can I get a thumbs up? Come on. Yeah, it's second law, my friend. Mr. Stitch is now second law. Yes. Can I get a thumbs up? Can I get a thumbs up? Thumbs up. Come on, guys. Come on. Oh, you're still confused? Yeah. And guys, let me warn you. Those ones, whenever you come to my channel and you say you are wrong, you are automatically blocked. Thank you, Mr. Karabo Mokwena. Yeah, positive comments are to be appreciated in this comment. Yeah, positive comments. Power to you, my friend. God bless you. Like, I really appreciate people who comment positively and who love my work. Wabo, really appreciate that, my friend. And I hope God will bless you. Thank you. Yes, yeah, now we are moving on the 4kg now. Ne? So now I want to explain some critical information about the 4kg. Hey, don't rush for calculations, why not? God bless you, my friend. God bless you. Don't rush for calculations. Don't rush. There are some people who still wants to learn the three-body diagram. Don't rush. We are coming. Don't rush. So let's come to the 4 kg. Ne? So we see now what kind of a surface do we have? That's the first question that you have to ask yourself. What is the first thing that you need to have? What kind of a surface are we having? It's an inclined. Ne? It's an inclined. Is it not horizontal? It's an inclined. So whenever you have an inclined surface, how does it affect the normal force and the force of gravity? Well, okay, we know over here the normal force, it will be equals to the force of gravity. Is that true? It's true? Yes, no, yes, no, yes, no. Yes, no, yes, no, yes, no. Thank you very much. Thank you very much. Here, they are going to be equal, my friend. On the horizontal surface, normal and force of gravity, they are to be equal. Remember, if we come here, ne, and I take this, let's just cut this and just project it here, right? Let's go back to the definition of the normal. Ne? Let's go back to the definition of the normal. Come on, guys, please tap the screen for me. Can I get 20k Pella? You see, guys, you are many here. You just say 1, 2, 3. We're on 20k, guys. Come on. 150 times 3 is 450 likes. Like just tapping the screen 5 times is 20k. So now here, let's go back to the definition. This is a question paper. This is a question paper, by the way. If it looks easy, it means you are lucky. This is a question paper question, by the way. So let's go back to the definition of the question paper. So the definition of normal. Sorry guys. The definition of normal. Thank you very much, Mr. Legit. Thank you very much, my friend. So now, remember, the normal, it is acting relative to the surface. Hey, thank you very much, Mr. Legit. Check. Today it means we are boxing, we are pushing. Keep on gifting our friends. Hey, my friends, come on. Thank you very much, Mr. Legit. God bless you, my friend. God bless you. Yeah, hey. So, guys, remember, normal is the force that is acting relative to the surface and perpendicular. It is acting perpendicular to the surface, right? Hey, thank you very much. Thank you to the power 50, my friend. Yes. Yo. Thank you very much. So, the normal, remember, it is acting perpendicular to the surface, ne? It is acting, yes, I think I have a definition here. The force acting exerted by the surface in contact with in contact with and acts perpendicular. Thank you. Yeah, we have to thank to the power 50. It's like thank you. So now no. What are you saying? Say I know I'm out of chapter, but the classes. Yes. Usually I start at 10 o'clock, at 12 o'clock. So now it is acting perpendicular to the surface. Even if you can see this, the normal here is acting upwards relative to the surface and is going to be perpendicular like that. Ne? So let's come here. We are going to have our normal. You see how it acts, how this normal acts perpendicular to the surface. Yeah, do it for your own benefit, my friend. Do it. So this is our normal force, like this guy, ne? And you see where this guy, where is he facing? Because of I'm trying to draw my normal force. Oh, it's this side, ne? I'm trying to draw my normal force being perpendicular to the surface, ne? This is going to be perpendicular to the surface, because whenever, even though I take this and put it on the horizontal, my normal is going to be perpendicular to the surface, ne? So I'm not sure if we understand each other here. Perpendicular to the surface, perpendicular to the surface. You see, I'm still maintaining my 90 degrees in contact with the surface. Now, what's going to happen with our force of gravity? Am I going to draw force of gravity perpendicular to the surface? Huh? Am I going to draw my force of gravity perpendicular to the surface? Yes, no? Yes, no? Let's answer. Yes, no? Thank you very much. Thank you very much. Why? The force of gravity, it always acts downwards. It always acts in the downward. So the force of gravity, it will always act downwards. And remember, from the center, guys, from the center, downwards. So the force of gravity, it will act from the center and downwards, like that. Doesn't change direction. It brings everything down. The force of gravity. I think the force of gravity. Ne aeroplane, ne phela, ne tonswane, down. As long as it has mass. Thank you very much for the gift. Yes, sis. Thank you very much. It brings everything downwards. Ne? So as it brings everything downwards, that's why now we have to break this force of gravity into its relative components, guys. Ne? Ne? So now, since we are going to break this into relative to its component, we have our surface being like this. Ne? And as we are having this surface being like this, we are going to break this into components. So tell me, let me test your knowledge, guys. Ne? Let me test your knowledge. Hey, thank you very much for the gifts. Yo. Thank you. So, what do you call those two forces that we are going to break this with? Can I have those two forces? You can draw the symbol. Yes, we have one. Can you... FG parallel, FG perpendicular. Yes. Can I have another one? Thank you very much. Yo. Yes, it's going to be FG parallel and FG perpendicular. X and Y. You're still correct, my friend. Because of Y, it is relative to the surface. So we are going to have... You see this force. This force, remember, why is it called FG perpendicular? Who can tell me? Perpendicular to what? Perpendicular to what, guys? Why is it called FG perpendicular? Hey, legit check. Thank you very much for the gift, my friend. I don't know. I ran out of thank yous. But all I can say is thank you. Whew. Thank you. It is perpendicular to the surface, guys. It is perpendicular to the surface. So this is going to be FG perpendicular to what? The surface. Right? That's why it is called an FG perpendicular. The applied force will be equal to the tension force. We know that the FA is equal to the frictional force. Guys, we are not talking about... I never said anything about applied force. I never said anything about the frictional force. I never said anything about the applied force. I never said anything about the frictional force. Let's come back here. Please focus, guys. Ne? whenever you're in this class, please, can I get your focus? Ne? Move with me. Ne? Let's move together, guys, please. If I never talked about the applied or friction, we don't include them up until I talk about them, because I'm breaking this scenario down. So now I'm having this guy. This is going to be our FG perpendicular, and we are going to have our FG parallel. Parallel to what, guys? I'm asking again. Parallel to what, guys? Yeah? It's going to be parallel to what? Thank you. It's going to be parallel to the surface. You can see where this is parallel to the surface. It's going to be parallel to the surface and perpendicular to the surface. So now we are still here, ne? We are still here. Don't lose focus. We are still here, ne? So what is this degree going to be? What is this degree going to be? This one degree. What is this degree going to be? I thank you very much. Hey, bafana bafundile. So we are going to have 40 degrees. Ne? So here I want to tell you something whenever I was in high school, what my teacher liked to say, but I will tell you now. So how do we calculate the FG parallel? Because obviously this is going to be the y, this is going to be the x, this is going to be our 90 degrees. So how are we going to calculate? And this, guys, the FG, the actual FG, which it is always pointing downwards, is going to be what? In maths, we are going to call this what? This is a 90-degree angle. In maths, we are going to call this what? Let's go back to maths. What is this in maths? What is this in maths? What is this? Thank you very much. This one is going to be a hypotenuse. Ne? The FG is going to be the hypotenuse. So I'm going to draw my FG here. So now, how do we calculate the FG parallel? Or the FG perpendicular? The FG perpendicular is going to be opposite. FG parallel, opposite, and FG perpendicular is adjacent. Right? So, yes, the FG parallel is going to be equals to FG sine 40. Right? Hey, man. Hey, man.
R E W D T Y G U R N
Y G U R N. Yeah. Yo, guys, sorry, I was doing a little bit of a query at TikTok with these techniques, so it's fine. So sorry. TikTok, it was doing me, hey, you know, whenever you go live and you have to do these things, but it's fine, we are back. So this is going to be FG cos, no, FG perpendicular is going to be FG cos 40 degrees. So thank you very much for your patience, guys. Oh, thank you very much. So now, you see, my teacher in high school, he used to say, if you want to remember this in an easy way, you just think, when you go parallel with your partner, you sin. If you're a Christian, you know what I'm talking about. If you go parallel with your partner, you sin. Ne? FG parallel is FG sine 40. When you go parallel with your partner, you sin. Yeah, some teachers, but it's fine. But if you got me, you'll pass this scenario. So this is what we're going to have, and this is what we are going to have. So do we agree? Like, do we understand each other in this part? Ne? Yes. Yes, do we understand this part? Yes, thank you very much. So now, yes, thank you for your patience. So now, let's draw a free body diagram, right? So let's draw a free body diagram. Let's start with the let's start with the normal. I like to start with the normal, ne? Here we are going to start with normal, ne? The normal force is going to go up like that. This is going to be the normal. The normal force is going to act, obviously, here, perpendicular to the surface, ne? So now, this is going to be the normal. And yes, you have a right to draw the force of gravity like this, but it is not advised. It is not advised for you to draw the force of gravity like that. But what I can suggest for you to do is to draw as legit check. Like we see you, my friend. Like salute for the gifts, and I hope God blesses you, my friend. He blesses for the last time. I am gifted today. So now I'm going to have this guy. What are we going to call this guy? What are we going to call this guy? What are we going to call this guy? FG, be specific. Yes, you can just represent with the letters X and Y. Or you can just say, yes, thank you very much. It's going to be FG perpendicular. Thank you very much for the gift, Mr. Legit Check. God bless you, my friend. So now, what do we call this guy? What do we call this guy? Nope, let me draw this very well. What do we call this guy? Yes, it's going to be FG parallel, right? And now we know what, let me stand well. We are going in that direction. We are accelerating in that direction, ne? So who can tell me what is left? What are we going to draw? Okay, let me ask this question. How many forces are acting as the resistive forces in this scenario? How many forces that are acting as a resistive forces for this scenario? Okay, there are two forces. So these two forces, I am drawing the right, but you should check something, ne? So what is the first? Can you please name them? Can you please name them? Name them, name them, name them, name them. Name them. Yeah, thank you, thank you, thank you, thank you. So it's going to be, I want to draw something. No? It's going to be F T and F friction. So yeah, ne? Yeah. We came a long way with this free body diagram. So now here's the last question. What is it that is wrong with this free body diagram? You know me, Mus. What is it that is wrong with this free body diagram? What is it that is wrong with this free body diagram? I'm asking now. What is it that is wrong with this free body diagram? When I saw when you attended my lesson yesterday. Most of the people are new here, but when you attended my lesson yesterday, so let me confirm. Let me see others. Yeah. What is it that is wrong? What is it that is wrong? Okay, guys, I'm telling you this. There is no way that the FT can be below F. It has to be another way around. You have to draw the frictional force and the tension force. There is no way that you can have your friction being below the tension, because the friction is acting on the surface like this, guys. It's acting on the surface, but on the free body diagram you are telling me hold the tension, it's above the friction. There is no way. There's nothing that is wrong here. It can't be on the right. It can't be on the right side. It's on the right side, or maybe it's the projection that I did. It's on the right side, the FG parallel, guys. No, this one is correct, guys. It's correct. And irrespective of whatever slope that you are having, whenever the slope is inclined, the FG parallel, it will always point down the slope. You get what I'm trying to say? Like, am I understandable? Am I understandable? You get what I'm trying to say, guys? Have to meet the line. Guys, the free body diagram, it doesn't have to be on the scale. Ne? The free body diagram doesn't have to be on the scale. This is a correct free body diagram. Just that this guy here, and this guy here, we have to have friction, and here we have to have tension, and this one obviously will be shortanyana, and this one will be longanyana. This is what you have to have. This is a correct free body diagram. What I was emphasizing now, you can't have friction on top of tension, because the tension is acting here, the friction is down there. That's what I'm emphasizing. There's nothing wrong about this. Am I clear? Am I clear? Thumbs up. Am I clear? Thank you very much. Thank you very much. Thank you very much. Thank you very much. Ne? Be careful when you draw the free body diagrams. Check things like that, because of sometimes you can lose marks over small things. But things like this, they are very important. The direction of the force is more important. Yes, it is important, but whenever you choose the direction of the motion as positive, you are finished. You are finished just by choosing the direction of the motion. You are finished. Like, you can You get it? Just choose the direction of the motion as positive. If the motion goes that side, choose that direction as positive. If the motion goes that side, choose that direction as positive. It's simple as that. So, you shouldn't be confused. So now we are having both of the free body diagrams, ne? We are having both of the free body diagrams, and now it's time for calculations. It's unfortunate for those who fail to be patient, but if you are still here, I believe you are the luckiest, you are the fortune. It's unfortunate. So now let's work with the calculations, ne? I'm just going to draw these two free body diagrams here. Q, and normal, force of gravity, tension, and F. And obviously I'm going to have this guy, our dearest friend, the normal, and FG perpendicular, FG parallel, and I'm going to have my tension and FK. Since the object is accelerating, so I will need this space for my operation. So now, let me just do quick. Okay. Yeah, we'll need this space. This one is going to be 8 kg, and this one also. Yeah, we are starting. We have this guy, the coefficient of friction. It means we can get what from this guy. If we have this guy, we can get what from this guy. Now we are busy with calculations. We can get what from this guy? What are we going to get from coefficient of friction? Let's start with the 8 kg block. What can we get? What can we benefit from the coefficient of the kinetic friction? Thank you very much. So now I'm going to focus a bit on the 8 kg block. So here I'm going to have the Fg being equals to Fn. Am I correct with this statement? Am I correct? It's going to... Thank you very much. Because now we are talking about the 8 kg block. Ne? We are talking about the 8 kg block. So now, since I'm having this, so I'm going to have my Fn being equals to mg. So what is the mass? 8 times 9, what is the answer here? What am I going to get as an answer? Okay, because of they are balancing each other, this force of gravity, it is balanced by the normal. So the object is not accelerating up or down. That's why they are equal. So what am I going to get as an answer here? What is going to be my Fn? Thank you. It's going to be 78,4, right? Is it 78,4 or 78,9? Let me fetch my calculator. You see, you guys, you are starting now. Is it 78,4 or 78? Let me fetch my calculator. 78,4 or 78. 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 78,4 Okay, so after, what are we going to have? Like, what are we going to calculate after this one? I know how, like, we get the Fn, so from that coefficient of friction, I know how, with the normal and the coefficient of the friction, what is it that I get? What I can get? What is it that I can get from the coefficient of friction and normal? Yeah, it's 78,4. What can I get from these two? From the normal and the... Hey, and remember guys, by representing this with newtons is very important. Whatever that you do, if you calculate the force representing this with newtons, it's very important. The SI unit in physics is very important. So what can we get from normal? From normal and coefficient, what is it that we can get? What is it that we can get from these two? What is it that we can get? People. Thank you. We can get the kinetic friction, guys. So we can get Fk is going to be equals to UK multiplied by normal. And guys, let me give you a free advice. Whenever you want to calculate something, copy it as it is in the formula sheet. Whenever you copy the formula, sometimes it can be represented by this, like this, or sometimes it can be written like UK is gonna be equals to it's going to be Fk divided by N. It can be represented like this. If it's like this on the formula sheet, copy it like this. Copy this formula like this. It's a mark. They are marking you correct for using the right formula. You're going to get free marks for using the right formula. But if you are using it like this and on the answer sheet is on the formula sheet it is represented like this, it's going to be the problem. It's going to be the problem, guys. It's going to be a problem. We get each other. Sisonke. Thumbs up. Oh, people, they no longer participating, but it's fine. So, UK is going to be what? Okay. What am I going to substitute my UK with? What is it that I'm going to substitute my UK with? What is it that I'm going to substitute here, my UK with? Thank you. Here is going to be 0,4. It's going to be equals to Fk divided by the N that we have here. Because of the purpose for us, like the purpose of us, let me remove this to be here so that people can see. So the purpose of us to calculate this, it was for it to help us to get the friction that we are looking for. So now I'm going to substitute this with 0,4, and now my normal is going to be what? 78,4. So I'm going to have my Fk being what? What is going to be my friction now? What is my friction going to be? Thank you. This is going to be 31,36 newtons. 31,36 newtons, So now we know we have this guy. As we are still busy. Remember, now we are looking for acceleration. We are going straight to acceleration. We don't care. As we are done drawing the free body diagram. We are going straight to acceleration. So let's see our free body diagram for our 8 kg object. So this one is for 8 kg and this one is for 4 kg. This one is for 8 kg and this one is for 4 kg. So now, since this one is for 8 kg and this one is for 4 kg, do you see how now we can look for acceleration? And guys, the acceleration of 8 kg, can I get a yes, no? I just need to know this, and it's very important for me to know this. Is the acceleration of 8 kg and 4 kg, they are different? Is the acceleration of 8 kg different than the acceleration at 4 kg? Is it different? Can I get a yes, no? It is going to be different. Yeah, ne? It is not going to be different. Guys, if you are carrying your baby, ne, with you, if you are carrying your baby with you, and you are running, are you telling me that your baby is going to accelerate more than you? You and the baby that you are going to be carrying, you'll be accelerate, like the baby will travel with the different acceleration than you. Let's say you're in the car, in the passenger seat, by the way, in the passenger seat. I'm not saying you driving, I'm saying in the passenger seat. Don't worry, you'll buy your car. So whenever the driver is driving with 140 kilometers and accelerating, obviously the velocity it won't be the same, it will change. Do you think, Hori, the person next to you will accelerate more than the driver and more than the car? Are you telling me that? For the last question, if you have the truck, good, and you have the trailer, and here's the truck, and here's the window, my nice window, and this is the trailer full of dump or full of whatever. Are you telling me what the truck is accelerating more than this trailer? Huh? If I calculate, if I measure the acceleration here, it's going to be different than the acceleration of the truck. So what makes these two to be different? Maybe there's something special. There's something special about these two objects. Maybe there's something special. So I'm asking for the last time, will this... Mara guys, if this guy decides to stop, this guy will accelerate or decelerate, because obviously he will move forward with the result of inertia, of which we know, but at some point when he moves forward, he will eventually stop. There's nothing that is different because of this guy. He accelerates relative to this guy. This guy, he's the leading object. Or maybe ke bolela China. Man. Maybe ke bolela China. But we understand each other, we get each other. So yes, the knowledge is here now. So let's continue. So now we're still on the 8 kg. We're still on the 8 kg, guys. Ne? Since we are still on the 8 kg, we have to calculate the acceleration. Equals to ma. Ne? We are still going to understand. Please guys, can I get a 40 key? Can I get a 40 key? Let me stop a bit so that people can get me to 40 key. There are so many in this life. Come on. Tap. Real people will stay and tap if you really support me. Come on, tap the screen. 40k guys. There are so many in this life. 40k. Tap the screen. Tap. People are not tapping the screen. Why are people that are not tapping the screen? Tap the screen, man. I will continue. Yeah. We play in December. I become kind in December. January to November. Shame. We are working, unfortunately. So yeah. And now we are going to have Fnet is gonna be equals to Fna. MA. Ne? So since Fnet is gonna be equals to MA, so we're still on the 8 kg. 8 kg. Ne? And we are going to focus on the forces that result to the acceleration of this object. How many forces that result to this object to accelerate? I just need a number. How many forces that will result for this forces to accelerate? How many forces? Thank you. There are just going to be two. Two forces will result to this object to accelerate, because we are only focusing on the horizontal forces which will cause this object to accelerate, right? So now that's what we are going to wena wenzani. If you are yenza lento leyo uzowazi ukuthi kwenziwani. Buza umbuzo kahle sizokuphendula. Now this force, we are going to have the tension and the friction. So on my Fnet, obviously, we are going to take, guys, advisably, we are taking the direction of motion as positive, ne? Even though you can take that direction as positive, only if maybe you know math. You know math. Yeah, no, join my private lessons. I'm live every day. Today I'm not sleepy. You are fortunate that I'm not sleepy. We can do this up until the sun rises. If you are serious. Me, I'm dealing with people who are serious. I get dealing about why the pelots up banana. Kre motho a ntebeletse go liveng se tsa beile phone go o tshwere ke borogonya go roba. O roballang o itse gore physics ya go beta. Physics ya o itia. Mara wena o nya go robala. Ai. Sa bona la pelo ya banana o nwe metsi. We are taking this to be positive. So now this guy, we're still on the 8 kg, right? We're still on the 8 kg. So now on the Fnet, how will my tension be? Positive or negative? Positive or negative? My tension is going to be what? Positive or negative? Tension. Thank you. Evan. Hey, thank you very much. Wabona people who are sure with their story, they will say positive. Guys, please, no crying emojis. Ne? Can we please, no crying emojis? TikTok does funny things. Because whenever, yes. No crying emojis. Can I please not to have crying emojis? Because TikTok e tlo nagana nka rena ke le ruta go gamble yanong la lelela ditšhelete tsa lena fetsa ba mblock. It's a serious thing, guys, ne? No crying emojis, cause insendela the restrictions mo wa ntlhaloganya. Now we are going to have our T be positive, but obviously the positive one we don't write or get positive wa ntlhaloganya. So now our T, it leads this force, it leads this object to accelerate wa ntlhaloganya. Because remember, this is the leading object. This object leads this one. So you can't tell me this will accelerate differently with this one. So this is the leading object. So this leading object will cause tension to this one to accelerate in this direction. So we are going to have our T. Remember this sigma. What is this sigma representing? What is this sigma representing? Is it sigma or is it stigma or is it sigma? Yes, it is the sum of, in this case, is the sum of what? It is the sum of the what? It is the sum of the what? Yes, is the sum of all the forces acting on the object. All the horizontal forces in this case. Thank you very much for more clarity. Thank you very much for more clarity. Is the sum of all the forces that cause acceleration. So now we are going to have what? We are going to have tension plus minus friction. Plus minus friction, but you can include the sigma in the F net in the formula. I guess you are right. I guess. Thank you very much, sir. You are very right, guys. Because this net also, it represents the sum. Thank you, Senzimela. Yes, they both represent the total. Thank you very much for the correction. But guys, we take mistakes. I also do mistakes. I acknowledge my mistake. So I remove the sigma. Because usually it is written like this. But whenever I say F net or the F sigma, or even though you say F sigma, but I never saw this. Ne? But let us use F net, because this one I saw it frequently. Ne? So thank you very much, my good sir. So now this is going to be the tension, this is the friction. Ne? This is the tension, this is the friction. They are both going to be equals to what? They are going to be equals to what? They are going to be equals to what? This both. Come on. MA. Yes, they are going to be equals to MA. So now we came with the first formula. Ne? Now we came with the first formula of the what? Of the 8 kg. So now how will our formula be like? So we're going to be, okay, let me just write this because of maths now. Now we are involving maths in. So since we chose this to be the direction, so I'm going to have my T and I'm going to have my minus, because this multiplied by that is going to be minus. So here's my value of the acceleration is going to be 31,36. I hope you gave me the right answer. It's going to be 31,36, which is going to be equals to what? My value of M represents what? Masculinity. It represents 8A. Thank you. Mass, yeah? So this is going to be my equation number 1. Ne? It's going to be my equation number 1. So let's take the camera where you are recorded. we are recorded. Ne? Let's go back to the 4kg. On the 4kg, how many forces that causes the object to accelerate? How many forces that causes the object to accelerate? Let me bring it closer. Let me bring it closer and closer and closer so that you can see it, the 4kg. Yeah. Aksana tolerance. How many? 3. Can you simply name those forces that causes the object to accelerate? Can you please name those 3 forces with letters? Yes, thank you very much, Mrs. Hope or Mr. Hope. You're bringing hope. Thank you very much for your positivity, for your positivation. Just imagine speaking wrongful English in front of these many people who are joined here, but it's fine, eh? So thank you very much. 1, 2, 3. These are the forces which causes this object to accelerate. So between these 3 forces, which force that we are going to represent as positive? Which force that are we going to represent as positive? Which force that are we going to represent as positive? FG parallel. It is going to be the FG parallel. Yeah, tension la errata. Hey, tension la errata. Can't take it. Jo. Wrong bush you. FG parallel is going to be the one which is positive because we chose this direction as positive. The direction of motion is positive, right? So I'm going to start with the positive force. Ne? So I'm going to have FG parallel. FG parallel. So how is going to be my T? Positive or negative? Positive or negative? Here's the free body diagram. We also the free body diagram, right? Wait, let me bring it closer. Because I'm tired drawing the free body diagram over there. Yes, we are going to have stand. Yeah. We are going to have negative T. And how will be my friction gonna be like? How will my friction be like? Positive or negative? Positive or negative? My friction is going to be negative or positive? Thank you very much. It's going to be negative friction. Ne? Which is going to be MA. Now, we are worried. We didn't calculate this friction. Ne? Because we see over here, we dealt with the 8 kg. But we are going to deal with the 4 kg. Hey, 4 kg. Can the 4 kg dintang? Now I want to know, is 4 kg equal to the force of gravity? Is 4 kg? No, is the normal of the 4 kg equal to the force of gravity? I want to know that. Huh? Yeah, ne? But it is equals to what? Eh? But it has to be equals to something because it's normal. Normal ne ke dichomitsa le na tsela normal o tshwana le dichomitsa le na tsela tsa o rata tshwara bike wa bona ba le ba rata tshwara bike ha khono te kemela le one hana exact calculation normal o phela tshwere bike that's why sna formula le di botse le dichomitsa le na tsa o lalla di answer tsa o lalla batho ba bangwe antlhalwa rata tshwara bike is going to be equals to the FG perpendicular. Remember, when we go parallel, we do what we seen. It means what is represented. Like when we go perpendicular, we cause drama. When we perpendicular to the surface, we cause drama. Okay, so I'm going to have my normal being equals to my FG perpendicular, right? Because of why? The normal force is going to be the resistive force for this guy. Like I said, normal bike. So this normal force will be, let me bring the camera closer. Okay. This normal force will be the resistive force for this one. And guys, please, I've been live. Please do the miss. Can I have at least 10 people subscribing to my channel? Here's my YouTube handle there. Whenever you need to know more, the recap of the lives, you'll go there and just subscribe. Here's my YouTube handle. It is pinned by Mrs. TK. And so normal or bike, so we are going to deal with them. So now, do I have a right? Obviously, the FG perpendicular is going to be equals to mg cos theta. Then my mass is going to be what? Let's help each other in terms of the substitution. My mass is going to be what? Yes, it's going to be 4. Obviously, this one is a constant. Cos. What is going to be my theta? We are helping each other with the substitution, Yes, it's going to be 40. Yeah. And let me give you a tip, guys. Correct substitution, it's a mark in physical sciences. If you want to get 100, it's easy to get 100% in physical sciences. You just have to know where you're working at. So you don't just write funny formulas. You see, writing the correct formula, it's a mark. By writing FG perpendicular is going to be equals to that one, it's a mark. Substituting correctly, the mass is placed here, the constant is placed here, and the theta is placed here, it's a mark. I'm giving you a tip. You take the formula from the formula sheet the way it is presented, and you show them how you are using the correct formula to calculate the FG, you are going to have 2 marks. This is just free marks. This 2 marks is just free marks. And the correct answer will lie to the answer. The correct answer, it's a mark also. So now, our FG is going to be what? Can I get an answer here? Okay, Bila, let me represent this information under 4 kg. Then FG perpendicular is going to be mg cos theta. This is going to be 4, 9,8 cos 40. What is the answer? Oh, 30, what? It's going to be 30,03. 30,03. So we know what is the value of the normal relative to the 4 kg. What is the value? Do we round off the answer? Nope, but you can represent it as a rounding off. Nope, but there's positive marking, guys. Even though you round it off, they will always mark you positively. Hey, Fulio, hey! Thanks for joining the live. Welcome, my friend. Welcome. Thanks for joining the live, my friend. Thank you. So what is the value of the normal? Guys, there's a positive marking. When you want to write or 30,013 what, or you want me to do what? To do this. Even though you don't round it off, you'll get an answer that is closer. That is closer and closer, because even the answer that you're going to get if you didn't round off, the calculator, the answer is still continuing. The calculator, it limits you. So even though you round off, you are closer to the answer. Like, let's not confuse each other on that part. Ne? Let's not confuse each other. Even though you round off, guys, I'm telling you, now, even the teachers, if you are watching, you know. Even though I don't round off, I will not be far from the answer. Maybe if the answer is 11,59, if you round off, maybe you'll get 11,7 or 11,8. There's a tolerance. There's a tolerance. Even though they discuss wherever, in the district, in the staff room, whatever, they will always, as long as here, let me tell you something, here, the purpose is not getting the right answer. It's knowing how to use formulas at the right time and how did you get to that answer that you are using. That's why there is something which is called positive marking. Am I clear? Don't be scared, man. Don't be scared. Do you think all the people who are getting 100% in physical sciences, they got those answers correctly and they are correct? Me, I can argue on that. But anyway, that's the topic of another day. So, what is the value of the normal? It's going to be 30,03 newtons, right? So yeah, what can we get from this normal? What can we get from this normal? Friction, right? We can get friction. Yes, no? We can get friction from this normal for this object. Thank you. We can get friction, ne? So, let's do it. Friction is going to be equals to what? K multiplied by N. Like I said to you, ne? This formula, sometimes it can come in both ways. It is not exactly like this. Sometimes, like, it depends on how is it presented on the formula sheet, ne? Hey, co-hosting, decline. If your formula is represented like this, like, use it. Firstly, write it the way it is presented on the formula sheet. You are going to get a mark. Ne? You are going to get a mark for using this formula, like for writing correctly from copying. It's like Control C, Control V. Ne? Control C, Control V. Copy and paste. If you are calculating for something that you need. Or sometimes you can be given this formula as UK being equals to FF divided by N. You can be given this formula like this in your answer sheet. You'll be given a mark for using a correct formula. Is that clear? But in this case, let's break the rules. We are going to have FK, or okay, let me just say FK. So FK is going to be 0,4 multiplied by the normal. Where is our normal? 30,03. So what is the answer here? What is the answer here? Can I get an answer? Can I get an answer? And can I get 40? Can I get 40? Can I get a 40K? Can I get a 40K? Hey, 50, man. 50, man. Before we continue, can I get an answer so that we can continue? Please tap the screen. Yes, it's going to be 12,01 newtons. Can I get yeah, before we continue, ne? I need 50k. 200 likes left. 200, 200, 200. Just a quick. Yes. Thanks to them. Salute, guys. And thanks for the 50k. Thanks for liking, being consistent with this life. And thanks for taking your lives very serious, guys. Ne? I'm really thankful for those ones who are taking their lives very serious. Yes. Yo. Hey, sorry. Hey, hey. Sorry. Hey, sorry for the hey. Sorry, man. Sorry. Sorry about that. Hey. But it's fine. So the answer is what? Yeah. 12,01, ne? So we are coming back. Yeah, now. FG parallel, we got it, ne? The FG parallel. Oh, we have to get the FG parallel. So remember, when we go parallel, we sin, right? When we go parallel, we sin. So let's get our FG parallel. It's going to be equals to mg sine theta. So what is going to be my m? Please tap the screen, guys. Tap the screen. So what is going to be my value of m? What is going to be my value of m? Here. Yes, it's going to be 4. This one is going to be constant, 9,8 sine. The theta is going to be the same, right? So it's going to be 40 degrees. So the FG parallel is going to be what? The FG parallel is going to be what? What is the FG parallel is going to be? What FG parallel is going to be? FG parallel, come on guys. What is the FG parallel? Tap the screen, guys. Tap the screen. Today I'm closing the live on 100k. Yeah, thank you very much. 25,2 newtons, right? 25,2 newtons, ne? Now let's go back to our formula. Ne? Don't be lazy for your own future. Hey, people are being lazy. Some of them, they are sleeping. You are sleeping. You expect miracles to happen. Huh? So I'm going to substitute the FG parallel with 25,2, and my t is gonna remain the same, and I'm going to substitute this f with what? 12,01, and I'm going to substitute this m with 4, and what do I have? I will add the like terms. So what is 25,2 minus 12? What is 25,2 minus 12? What is 25,2 minus 12? Thank you very much. It's going to be 13, what? 9. 13,19 minus t going to be equals to 4a. Now you can see where we have our equation number 2. Tap the screen, guys. Tap the screen. So yeah, I'm gonna wipe this because I no longer need it, and I'm gonna wipe who? Yeah, I'm going to be left with that. We're on fire. Then we make inequality judge. So okay, I want to see how people approach this simultaneous, because I want to see people approaching this simultaneous, and I want to see how do people deal with this thing. So whenever you get here, what do? I want to see what people they are with me. What do you do when you reach here? What do you do? So we make the subject of the formula. The subject of the formula. Okay, we get number 2. I want to have 10 comments, and I want to see what do people do when they get here. Equation 3. Okay. Okay. That's the first. Equation 1 plus equation 2. Okay. So, okay, we have no people responding. So let's continue. In the meantime, can you please get me to 55? So now, okay, transpose, substitute, okay, let me show you the easy way. I think I like the method. Yeah, Bridget, ne? Bridget, yeah. I like the method of Bridget, because that's the method that I like to use. If you go back to the comment there, Bridget, you will see what she said. You are just adding these 2 equations, guys. Me personally, I feel like this one of the subject of the formula, it's a long method, unfortunately. Me, I like shortcuts. Me, I like shortcuts. But me, what I will do, I will just add them, these 2. I will add them and try to eliminate this t, because I know I have t here and I have negative t here. So whenever I add the 2 formulas, whenever I add the 2 formulas, do you see what is happening? I'm going to add negative 31,36 and 13. Why ngare mo re tlo bona bothata mo? I'm going to add this and that. Whenever I add this 2, what do I have? Whenever I add this 2, what do I have? 13 and 12. Because whenever I add this 2, I will have this t and that t cancelling each other. And whenever I add this 2, what do I have? Oh, negative 18,17. So I'm going to have negative 18,17. Ne? I'm going to have negative 18,17. So it's going to be equals to what? 8 plus 4 is going to be 12. Going to be 12a. Then divide by 2, then acceleration is going to be how much? This and that will cancel each other. And what is this going to be? What is this going to be? What is this going to be, guys? Yes, it's going to be negative 1 comma 51, which is going to be equals to A. So is the system accelerating if we have a negative answer? Is the system accelerating? No, it's not moving back. It is decelerating. It is decelerating. It's not moving back. Ne? It is decelerating, guys. Get the knowledge. Ne? People, they are afraid or they will get a negative answer. This has a meaning. It means sorry, it is moving forward, but it is decelerating, which means at some point it will stop. Do you get what I'm trying to? Yes, it is slowing down, guys. Do you get what I'm trying to say? Because remember, not all the cases this will cause the object will accelerate, or maybe it will accelerate because you might find or at before, because of like this, it was moving. Before it was moving, but whenever it reaches this part, it is deceleration, which means this one, it drags this guy. So it is deceleration. Yes, thank you. Yeah, the acceleration in the it is negative, so there is more accurate in the one line. Braga, if wena o nyaka go robala tsamo robala o ilo practice go shwa go robala go practice go shwa tsamo robala o ilo practice go shwa braga one because rena ro robala ga December. So this guy, this is going to be A is going to be equals to 1,51 meters per second squared. Opposite. Direction. We are done. It is deceleration, which means, yeah. Do you get it? Do you get it? Now let's calculate the tension. Let's calculate the tension, guys. Let's calculate the tension. So what are we going to have as the tension? What are we going to have? Let's take this guy. Let's take this guy. And let's see. We are going to have T minus 31,36, which is going to be equal to 8. And obviously, remember, yes, thank you very much. We are plugging in equation number 1, right? So we are going to plug what is going to be negative, the negative value, because this one it's in the opposite direction. So it's going to be negative, 1,51. Then what is the multiplication here? If we multiply the two, what are we going to have? What are we going to have if we multiply the two? What are we going to have? Yes, it's going to be negative 12,08, which is going to be negative 31,36, which is T. Right? So we are done with the acceleration. I'm going to wipe. Yes. So now we are going to take this to the other side. And we are going to have this being equals to negative 12 and plus 31,36. So what is the answer here? Can I get an answer? Can I get an answer? Thank you. Thank you. Yes, it's possible. It's possible. Actually, t is negative and positive, guys. T is negative and positive. Remember, here we are having third law. Here we are having third law. Ne? So it means this guy, it drags this force, this 4 kg, it drags this with a positive force, and this guy, it pulls back with a negative force. So that's why we have the tension. Here we are having third law. If you know the definition of the third law, this is what is happening here. So hence we are having what? What is the answer here? It's going to be, yes, our T is going to be equals to 19,28 newtons. In this case, it is for what? In this case, it's for equation number 1, right? And since it is the equation for number 1, it means that the T is going to be positive, which means it's going to be in the same direction, but opposite with the acceleration. You get what I'm trying to say here? Do you understand? How do you approach this? Because remember, the system, it slows down, right? The system, it slows down. So this 19, what is going to be chosen by this guy. This guy is going to be chosen by this guy. But the system, it slows down, and our acceleration is negative. So it means our tension is going to be positive for equation number 1, but negative for equation number 2. Hey. Thank you, my good sir. Thank you. I don't want to. What's your name, my friend? Karen9th. Yeah, Karen9 the Hood. Thank you, guys. Positive comments, my friends. There. I'm not a lecturer. I'm a tutor. I'm a reflector. I'm an engineer. So, yeah. Yeah. Don't worry, guys. Unfortunately, I will have to end this session. So, would it be still correct if someone will substitute? Yes. You have to get the same answer, but with a negative sign, I believe. Ne? Yes, hopefully. But that's why I prefer to tutor, my friends. I live in Pretoria. I live in Pretoria, my friends. But I don't like to work. I don't like 9 to 5 thing. I like to have my students. Yo, that's a sad truth when I but yeah, the next session is going to be today around 12 I do midnight. Just that today I started late, around 2, so it's 2 to 4. Like, yo, I appreciate people who take their lives very serious. Hey, ya re betha mara ai nka se re thibele di-channel tsa gore re rute bana content wabo. To give back, it's very important, my friends. Based on motion into dimension. Yes, yeah. You can ask. Based on into dimension, you want to ask what? Acceleration on the y, acceleration on the x, using theorem of Pythagoras to get the acceleration. Hey, What do you want to ask? Are you talking about you want us to talk about dynamic mechanics, static mechanics? Hey, what do you want to ask? Or stress and strain? What do you want to ask? As we are waiting, can you please get me to 60k, guys? Just for appreciation, Ninji. 60k. And guys, please subscribe. Yes, please subscribe. It's your number on my bio. It's my number on Mrs. TK's bio. Mrs. TK, do you have my number on your bio? I think if you go to Mrs. TK's bio, you'll get my WhatsApp number. But otherwise, if you need private sessions, make sure you DM me. Because me, when I post my number, yes, yeah. Oh yeah, can you please go to Mrs. TK's bio? That's my number there. Don't be scared. You can even follow her for more inquiries. At the constant velocity and the main fire the rifle up. Will it go back? Constant velocity and the men fire the rifle up. I think you'll have something like this, my friend. Hey. That's the trajectory. You are asking based on... Yes, it will move like this. Okay. You're moving. You're moving in which direction? Horizontal, and you fire up. Yes, the bullet, remember, the bullet, it has what we call, what do you call it? Rotates. And when it rotates up, due to air friction, and it depends on the air friction, or maybe if the air friction is isolated, it will move, because the car is moving, so it will move like, I'm not sure, yeah. My logic sense, it tells me, or it will rotate something like, then just the set part, when it comes back, the bullet, it comes back spinning. Did you know that? And obviously when you fire it up, it will move due to inertia to the side, to the direction. What? It will move. I'm not sure if I answered you. Hey, that's a critical one, my friend. Hey, now you're getting in my mind. But when I think of it, if you drive and you fire up, obviously the bullet will spin up, ne? But it will spin up at the same time, moving horizontally due to inertia. So you will have something like this. Yeah. Due to inertia, the bullet will move slightly to the, like it will move in the direction that you're traveling at. I think that's it. That's a level 4. That's a level 4. Not exactly the same velocity as the car, no. But for a moment, it will start by having it will start for a moment, it will start, like, it's like Joe. The concept of inertia, ne? The bullet will adapt to the position, like to the speed of the car, right? And when it adapts, starting from the velocity of the car, moving up, but due to, it depends on the air friction. But if the air friction is neglected, if we are not talking about the air friction here, the bullet will move up, but at the same time it will move. Let's say the car is moving in that direction, ne? The direction that the corky is pointing, and it moves at the constant velocity. So, and whenever you fire up, ne? Whenever you fire up, or maybe if it moves in this direction and you fire up, so the bullet will move up, at the same time it will move in this direction. I believe I answered you. I am closing this session. Or maybe I don't know. You have a different answer. Let's education. Yes. Even though you go through my profile, you'll see the highlights of maths. Yeah, but that's a good question, my friend. Hey, you just jogged my memory. That's a good question. Yeah, and hence you can calculate the what you call just that with the bullet. It depends. You have to put the conditions. Because did you know when you fire the bullet, it spins? That's why it goes straight. If the bullet wasn't spinning, it was going to be like it was going to spin like. That's why we have what we call inside the gun. There's a revolver. Yes, there's a revolver which controls the motion of the bullet. So whenever you get gunned, the bullet spins like this, and it penetrates your heart or your lungs, then you are dead. That's why when you fire up, it will spin up, but it will spin like going in the side. That's why I'm having this on Chalohai. Because why? The bullet will maintain, for a moment, it will maintain the speed of the car. And when it maintains the speed of the car, it's due to what? It's inertia, that thing. Because at some point, it will reach its rest position. Because due to air friction, it will have to stop. And it will come back again. That's why I'm saying, whenever it reaches this turning point, but when it comes back, the bullet, it will not come back spinning. It will come back spinning like this. Spinning like this. That's why people, they have a wrong misconception, or maybe when someone points a gun upwards and he shoots, the bullet will come back like, it won't come back in this form. It will spin. And it will spin in various directions depending on the air friction. Because of the air friction depends. Like the direction of the wind, it can be left or right. It depends. Maybe it supports, or maybe it becomes the friction. Hey, that's a critical one, my friend. That's a critical one, my friend. But yeah, that's a joking question. Yeah, that's a joking one. So yeah, it's a pleasure, man. It's a pleasure, man. So yeah, for private lessons, yeah. But if you are doing something like those lines, along those lines, engineering physics, what? That's engineering physics, by the way, ne? Yeah, that's engineering physics. I did that, like dynamic mechanics. It's called dynamic mechanics. There's static mechanics. There's dynamic mechanic. What affects the bullet to fall? Force of gravity. Becomes a free fall, my friend. It's force of gravity. It will fall due to gravity. But hey, yeah, thank you very much, guys, and I hope God will bless you. And for those who need extra lessons, come on, I charge only 200 per month. Effective, cheap and effective. Charge 200 per month. And can you please go to Mrs. TK's profile? Mrs. TK's profile, the number that you see on the bio, it's my number. Or you can even text her for the inquiries, because we own the same business, we own the same business, just that she doesn't do physical sciences, she does other subjects. But me, I cover physics and maths. And there will be a formal website there where we are going to explain everything about our business. There will be a formal website that will explain everything about business. We are still busy at it, but I'm sure in few days I will be posting my website, and yeah, you'll get everything there. And let's support each other, guys. And yeah, I'm not wishing fail to anyone. Like, we are here to help each other. We are not here to prove the points. If you do need one, please text Mrs. TK. Like, go to Mrs. TK's bio. Here is that. She even pinned my YouTube channel, and that's my YouTube channel. So yes, thank you very much. Thank you. We'll talk. If you inbox, yeah, on TikTok you can inbox me. Yeah. Everything in G. We are working to each other. I'm Mr. TK, she's Mrs. TK. Babo. And yeah, we're on the same line of business, so we are going to help you. 200 per month. I won't change my statement, as I'm telling you. It's going to be 200 per month. If someone utikiranna and we charge 500 against, because now we charge 200 per month. Maths 200, physical sciences 200. Yes, maths as well 200, physical sciences 200. Same business. You inbox, we work. In the meantime, it doesn't mean or like if I can't provide those. If you don't have that money, please subscribe on my channel. Subscribe on my channel on YouTube. I'm always updating my work. I'm always updating my work, and if you are looking for the recording, for the specific part of the recording, DM, I will post it. But I will only help those who subscribed. I don't like working with people who doesn't follow me. You don't follow me, but you need my help. We don't work like that. Or maybe you come here, you want to prove a point. I'm not here to prove a point. I'm here to help your child, or I'm here to help you rewriting. Yeah. Don't forget to like, share, and follow. And yeah, thank you very much for 60k likes. And don't forget to pray. Billy, my friend, this is the end of the session. My friend. But thanks, Joe. Thanks, though. But yeah, I guess we will meet, yeah. Sorry man for not, yeah. This is the end of the session, guys. Thank you very much. And yeah, have a lovely day. I'm going live again today around 12. Live. We are pushing.